Welcome to the second part of the video tutorial on how to count features in multiple GenBank files. In the first part of this tutorial, we were able to count the features and place them in different output files. And these are the files. So let's open them. So when you open them, you have the counts in their respective files. But then with this current arrangement, it becomes difficult to compare one file to the other. If you want to do the comparison, you need to open each of the files and then view and do the comparison. But we can make it much simpler if you combine all this information from the different files into a single file and then make it into a single table, such as the one I'm displaying now. And that is why this tutorial is being made. So let's go back to the Python interface and start the activity. So what we are going to do is to first download the GenBank files and then put all of them in the same folder or directory and count the features using Biopython. Then combine the results and store in a single data frame, which we then save to a single output file. And to help us do this, we will use the following Python libraries. We are going to use Biopython and pandas. These are the instructions for installing them. There are also videos that shows how to install Python packages using paper and anaconda, so I'm going to leave those also in the description box. So now that we are set, let's begin the activity. We are first going to download the GenBank files. So I am going to demonstrate the download process using this example. This is one of the GenBank data we are going to use. So you first visit the NCBI page. I'm going to leave the link in the description box. So use that link. So when you use that link, you'll come to this page and then we'll download the GenBank file. So this is how we do the download. So first of all, you come to this section here, this side, and then click on the send to. Then you make sure complete record is checked. Then when you come to choose destination, you select file. Then when you come to the format, you select GenBank 4. Then you click on the create file. And then you save it. Because we are dealing with multiple files, we are going to use their respective names to avoid file conflict. So we say AR465.gb. Save it on a desktop because this is the name of the string. So please follow the same instruction to download the rest of the GenBank files. I mean the 4 GenBank files that are left. So once you are done with that, we move on to the next activity. On the Python interface, we begin by first importing our libraries. And these are the libraries. We have the globe, Biopython, counter, pandas, OS. Some of them are not library specific, but they are functions or models. But all these are required. We will need them for the activity. And I'm going to explain what each does later on. So after importing the library, we are now going to set a path of the directory that contains the GenBank files. So we see file directory equals this is my directory that contains the GenBank files. Please know that yours is likely to be different, so you put the appropriate path there. So let's run it. After that, we get the file names, and we are going to use the globe function. We are going to assign the operation to a variable. So we say genfiles, and we use this. Now the globe function allows you to specify patterns that it can use to get the file names for you. So here what we are doing is that we are asking globe to go into this directory and then return to us all file names that end with .jb. Remember that the files we downloaded had the .jb extension because they are GenBank files. So that is what we are doing here. So let's run it. So we have the files now. Let's query it. And these are the files. There's a list objects. So we can even query for, let's say, the first elements. So we say genfiles, and we have it there. So now we need to move on to the main activity, which is the counts. So to help us do the counting, we are going to use functions and loops. Functions will be used to read the files and count the features, and the loops will be used to iterate over the files and count the features. So we begin. So we begin by creating a function to read the GenBank files. Please note, I have a separate video that explains this code. I'm going to leave that link in the description box. That video talks about how to access or read GenBank files, so please do that. Let's look at the next function we are going to create. The next function is going to count the features. Now here, this function will read a GenBank file and extract the features for us. And then this function here will accept the features coming from this side and counts them. Again, there's a video that shows how to count features in single GenBank files, and I believe that can help you to understand this code as well. So please watch that. The link is in the description box. Now, some of the features might not be present in all the files. Some might be present in some files and might be absent in some files. So therefore, we need to make sure we have streamlined this thing so that the counting is done for all files. So we need to first scan and extract all the features from all the files. So a third function here will help us do that. So this function will identify the features in all the files and aggregate them for us. So look at this as what a summary of the features that we are expecting to get. So here the iteration is done on all the files, and then the function here is called to read the file and bring out the features. Then the features will be stored. When we come here, we are using the set function. So this one will remove duplicates because we are only interested in the summary, not the actual count. So this will help us to get those features. So we run this function as well. So after that, we begin by getting all the features. And to do that, we say all features equals, and then we call this function here. So we say scan or features, and we feed it with the GenFiles list, and we run it. So let's bring this up a bit. So let's run it. So now we have it done. So all the features have been identified because I issued a print statement here to help us to detect it. So let's print those features. So these are the features, and these features are the ones we are going to count. The features we have here, as I indicated, might be present or absent in some files. So the counting will be done, and then we'll see which files contain which features. So before we do the counting, we need to create an empty list. This will be used to store the counts that will be generated for each file. So let's create that list. So we see all feature counts equals empty list. So now we can begin the counting. Because we are dealing with multiple files, we have to apply the loop. We are using the for loop. We will use it to iterate over the files and count the features. So this is how we are going to do it. So this loop will iterate over the files, and then for each of the file, we are going to get the directory name and then the file name, and then we are going to strip the file name of the extension because the file name will be used as a label. Then we get the feature types from the functions we created. Then the counting will be done. After that, we are going to put the count in this temporal list. Because we are iterating, the values might change depending on which file is being analyzed. So for each file, we push its results here temporarily, and then we add some additional information to this list. And then we now finally append this particular content into the main list we created here. But of course, some features might be absent in some files. So that is why we have this section here. So if the feature is present in the count that was returned, then we append its counts. But if it's not, then that means that the count is 0. So we append the value of 0. Then we push it here. So that is how we do it here. It's very simple and easy to understand. So let's run this command. So let's do it here. And then let's run it. So the running is now complete. And notice these statements here because I placed them in one of the functions to do the counting and notify us. So this tells us that the features have been counted, and there are 5 of them. So that means we're on the right track because we are dealing with 5 GenBank files. So the features have been counted, and the results were assigned to the all feature counts here. So let's just query and find out the length. That will help us to make sure that the activity was successful. So we say len all feature counts. So we have 5, which is good because we are dealing with 5 files. Let's print one of the elements here. So let's say all feature counts, and we look for the first element or the first member. So this is the member here. So this is what for file vin521. We also have the count here, but here we can infer which counts belongs to a particular feature using an earlier information. Notice before we did the counting, we scanned for all features. So it is from these features that the counts were done. Iteration was done on each of these features in a sequential manner here. So here we can infer. So let's print the features again. Print all features. So here, using the information here, tRNA is the first. So it will map to what? The first value here. Gen is second, so it will map here. Source in that order. So that is how we can infer from this particular data. Now let's print all the feature counts lists here. So we say all feature counts. We have this here. But when we have this, it becomes a challenge if a different person is reading to get this information. So we are going to properly organize this by creating a pandas data frame and storing these results in it. And in the process of creating the data frame, we also need to put what? Labels, where the labels will be the features, so that we can properly read and interpret these results. So first, we need to create the column headers. So these columns will be for the data frame. So we create an empty list first. We say columns equals empty list. Then we append the word file. So this file here will be the header for this first column here. After that, we add the features here. So we say columns.extend all features. We now run it. So now let's print the columns. So we have it nicely done for us here. So now we can create the data frame using pandas. So we say data frame equals pd.dataframe, and we specify the all feature counts because that is the data. Then we specify the columns. So we say columns equals columns. So we run it. Data frame has been created. Let's print it out. So this is the data frame. So notice how nicely the data has been arranged for us. So now we have what our columns and we have our values also here. Now with pandas data frame, we have column headers and we also have the index. This side here, this numbers here represents index. Indexes and columns are used to make queries. So you can specify an index which is for a row and then a column, and then you can get the value that is in that particular location for us. But before we do that, let's first make this file here an index, because the names here are also unique, so we can use that as indexes. So we do this. Now this is the original data. We don't want to modify it, so we need to make sure we create another copy and do the modifications on it. So we are going to assign the next operation to a new variable, and that is what we are going to use. So let's set the index. We say final data equals dataframe.set index. So let me put this column here, this title here. So we say set index to file. Okay, so now we do it. So we set the index, we specify the column name, which is file. Now we are done. So let's run it. So now let's print the final data. So we have it nicely done for us. Now, there are times where you would like to remove a column or delete a column from a data frame. So I'll demonstrate with an example here. So here, let's remove the source column, the MISC binding column, and the regulatory column. So let's remove this. So pandas will help us to do that, and we are going to use the drop function. So first of all, let's create a list to contain all the columns we want to delete. So we say columns to delete. So we create the list. We want to remove source. So it should be in the list. We want to remove MISC binding. It should also be there. We also want to remove regulatory. So let's do it. So we now have the list there. So here we can now remove it. So let's say remove columns from data frame. So we see final data dot drop, and we indicate columns equals columns to delete. Here, because we are using a copy, we can modify the current data frame. So I will say in place equals true. Then I'll run it. So now it's done. So let's print out the data frame again. So we now have it nice. It has been arranged for us nicely. So now we know what our column stars, the features, the counts, and then we also know the files. But pandas is not only for storing data. You can use it to query data as well. So let's look at how we can query information from a pandas data frame. We are dealing with just some few examples. So let's say you want to find the feature count for file within 521. How do we do it? We say final data dot log. We specify the index, which is within 521, and then we say we want all columns. There's a comma. We have all columns here. That's what the colon is about. Then we run it. So now we are going to have it printed here for us. So this is nice, and it's good for arranging your data. Let's query another one. Let's say you want to find the feature tRNA. Let's use gen. You want to find the gen counts for file within 521. We can say final data dot log within 521, comma, and we say gen, and we are going to have the counts here for you. It's the same as what is here. So this is how we use pandas to manipulate and store data. Now we are using pandas data frame in a Python interface or in a Python environment. So we want to store, or we want to save this data frame to an output file. So let's do it here. So To save to an output file, we need to first define the output file name. It is important. So let's define it. So we say output file equals /home /cogna /desktop /picturecounts.csv. So this is the file name, and we are saving it in this directory, desktop. You can also choose a different path on your PC. After that, we save the final data to a file, and it has to be in the CSV format. So we do it. So we say final data dot to CSV, and we indicate the output file because we have defined it here, and we say index equals true. So we save it. Now it has been saved to the desktop. So let's go and check it out. So this is the file output. So let's open it. Good. So now we have it here, nicely done for us. So notice how it's now easy to compare the files to each other. So even compare the features to each other, and then compare the features to other features in other files. So Python makes it possible to organize your data as such. And today I'll say this is all for my video, and I'll see you in the next session. Goodbye.